Hello! There are different types of capacitors. The ones that I'm addressing here are the aluminum oxide electrolytic ones, which are very common metal cans, usually wrapped in some plastic for insulation. So please note that any other type of capacitors will have vastly different properties and rules. Why do you replace electrolytic capacitors at all? For that, we need to have a look into one of them. As you can see, it is made of two strips of metal foil, the plates, with two strips of insulation in between, wound up in a roll. That doesn't seem too problematic, does it? Well, it's the thing that gives the capacitors their name that's the problem, the electrolyte. You see, this roll would not work very well when it is dry. It gets dipped into a liquid, the electrolyte, which is soaked into the paper-like insulator layer. And here's where the problem starts. Nothing is 100% effective, and so the seal of the housing will leak ever so slightly, allowing the electrolyte to evaporate. Keeping the can tightly sealed is also problematic for laymen. Electrolytic capacitors are polarized. If you put it into operation the wrong way around, it will cause the electrolyte to separate. Kind of like electrolysis in water, which turns it into gas, and the pressure inside the can will rise until, well... Let's have a demonstration! Nope, better use a smaller one. I still need my house. There are non-polarized ones around, but these are rarely used these days. The only place I ever came across these was in the CRT unit of my SX64. Should you replace them? Well, if the device in question is older than about 20 or so years, or has experienced excessive heat like car hi-fi stuff, then I'd say yes you should. If you replace any of those caps, you need to select the right values. But these have two values, an F value and a V value, and usually some squiggly lines too. Let's look at the values by example of 47 something F/16V. This reads as 47 microfarad at 16 volts. The first value, the farad or F1, is important to get as closely as possible. It defines how much electricity the capacitor can store, and the circuitry around it is usually somewhat tuned to that value. The second value is the voltage rating and indicates the maximum operating voltage of the capacitor. If you replace one, you need to have at least the same value for that, but it can also be slightly higher without any problem. I would not replace a 16 volt one with a 400 volt one, but picking 25 instead of 16 or similar is not a problem at all. How do you put them in? Well, there's usually either a printed band on the side or there is a dent in the can. The marker usually points to the negative lead, the dent is the positive. New ones also come with a shorter and longer lead, but I wouldn't bother memorizing those if you deal with used equipment. One question remains. Why do we have some leeway in the capacity value? Easy. Electrolytic capacitors are not precision instruments. Even high-quality new ones will come with 20% of tolerance. Yes, 20%. Which means that in almost all cases, the design of the circuit will take that into account, and they will most likely be used like a buffer battery only. As long as you get close enough or slightly higher, it should be just fine. If there is anything tuned in the circuit, like frequencies, it will not use electrolytic caps and usually also have a trimmer cap or potentiometer next to it as a rule of thumb. I hope that clears up a few of the questions around electrolytic capacitors that you never had the idea of asking before. If you liked this kind of video, please let me know in the comments and I might do others. See you later!